Okay guys, just a little intro for this section on first order homogeneous differential equations then. We're given a differential equation that looks like this then, say dy dx equals f of xy, and basically it's homogeneous if all terms on the right hand side are of the same order. Then we say the equation is homogeneous, and what we mean by that is we mean that if we look at this example, for example, that's of order 2, combining this term's of order 2 and this term's of order 2, so everything's of order 2 here, so it's said to be homogeneous. And this one here, this is of order 3. Combined, this term's of order 3, and this combined term is of order 3, isn't it? And here, in the last example, this is of order 1. Again, this is of order 1, 1, and 1. So all the constituent parts are of order 1. So it's described to be as a homogeneous first order differential equation if we have dy dx is equal to this, or this, or this, of course. Okay then, so that's just all there is to this. And basically when we see a first order homogeneous equation in this form that we recognize, we can simply use a substitution y equals v of x. That's what we do, and we solve the resulting separable equation. Effectively, if y equals v of x, what we essentially have then is that v is equal to y over x, isn't it? So that's what we have effectively. So if we look at the right hand side, let's look at this one for example. If we divide by x top and bottom here through all the terms, this will be a 1, this would end up being a 2v, this would be a 3, wouldn't it? And this would be a minus v. So this is what we'd have in terms of v. In terms of dy dx, we need to differentiate this thing here. So let's just do that then, just to highlight that, because it's the same every time. So we'll do that then. So y equals v of x. And now we're going to differentiate this product using the product rule to get the left-hand side dy dx in the substitution that we need. We use the product rule, u dv dx plus v du dx. So the u in this case is the symbol v, which is rather confusing. So it's u, so I'm just going to write it down, dv dx plus v times du dx. So I know it's slightly confusing, but that's what we've got. And that's v plus dv dx. It's the same every time. So I'll dv dx, that's right. So there's our left-hand side, and that's what we put in the substitution for dy dx. On the right-hand side, we'll be finding out what the value is, which for this one, it was that value there. So we make that equal to that, and then we solve the resulting differential equation. We have to move the v across, and we can then separate the variables in the equation, solve for v, in terms of x, and then once we've got v, we can put back in what the y over x that v was equal to in the substitution. So that's it, that's the method. There's 10 questions in this section. Hope you enjoy them or benefit from them. And any feedbacks by an email is always appreciated, of course. So all the best then, and I'll catch you in the next section. Cheers!